So let's start. Do everybody hear me? Yes? Okay, let's start. Where does this hat come from? From which country? Yell it. Not Holland, it is no carnival. No, what is it? Which country? Tibet, you're right. Unbelievable, what a shot. It's about, my talk is about domain-driven design, micro-frontends, and AI. He's the AI guy, and I'm talking about domain-driven design. So I've cycled 20 years ago from Holland to Nepal and Tibet. And there is my starting point. There's also a link with this hat, of course. Here I'm cycling, and I met some guys on the track, and we decided to go to a jungle lodge. So yeah, let's do that to see some tigers and rhinos and great big elephants. So it is the lodge where we were staying, and okay, in the morning we went into the park with some guides, and okay, we didn't see anything, only a little bit monkeys and some footprints of some tigers. So no, and suddenly I saw a silhouette of a rhino, and the guide was yelling, "Oh my God, what a!" It was and rhino. I said, "Yo, don't yell!" I said, "You have to jump everybody in his own tree." So everybody was climbing in this tree, and I was standing on a branch as high as the nose and the horn of the rhino. You feel it, huh? Okay. So, and suddenly he was hearing us because the guide was also standing on my branch. That was not, I should not do that, but he was yelling and he was really screaming, and I, silent. I said, he was really crazy, and he was steering his ears like radars. And suddenly he's going to walk very fast towards my tree. Yes. How fast can an Indian rhino run? How fast? Is it A? But we were, yeah, hands up. A. B. Wow. C? Yes, yes, yes. 50 kilometers an hour, unbelievable. So it was, I was very afraid. So I was standing there on a tree, and so I'm Eijgermans. I'm from Soprasteria. I'm a front-end architect, and I do the talk about micro-frontends and DDD and AI. And Urs Wieske, he does the AI part.
Hi, can you hear me? Or do I need to scream? Okay, okay. Yes, my name is Urs Wieske, and I'm a ex-colleague and freelance architect, software engineer, and my base is actually Java. Are there people here from Java technology? Okay.
And
yes.
Python.
Python, TypeScript, JavaScript.
Hey.
Whoa, okay.
Oh, wow.
Okay, so I'll be talking about the process from solution to design. Peter will talk everything about the DDD strategic design part, and I'll be hooking in on the path to design.
Okay,
yeah.
Thank you.
Yeah.
Now let's start. The table of contents is, I start first with the monolith, of course, and then I split it up with domain-driven design. Afterwards, we do some AI, yeah, quite big part of it. And micro-frontends I showed you, and module federation. Yeah, make a picture of me. Yoo-hoo! No, okay, I'm not so... And the real-world app I show you also about the Dutch railway system I want to show you. So there's also, I want to talk with about, start with the monolith, of course. This, how do we survive such a monolith? Yeah, the monolith in my context, it is the Rhino. And most of the organization starts normally with a monolith. It's good, you can develop quite fast in the beginning. But when the application grows, there's a lot of code bases, and it's costs a lot of time to deploy the application, etc. Difficult to scale. Everything is tangled together. So how do we survive this Rhino, this monolith? First, you have to break down your Rhino into smaller pieces. You can imagine as some cute animals running around. You can move them. They are independent animals. You have to split them up. This is similar. You can split up your monolith into little applications, and yeah, that is better, of course, than one huge monolith. You can handle it better. You have to find cover, of course, in the jungle. Okay, you have to isolate your code in one module or separate modules. That is what you want, of course, when you build a application, and also just resilient. Your application, of course, more resilient, because when you have an issue in one module, it has less effect on the whole application. And the third part is that you have to be agile, of course, in the jungle. Think fast to survive the Rhino. And on the other hand, you can, with all those separate modules, you're also quite agile, because you can make changes quite fast, and also faster update cycles, and happier customers, of course. And the applications are, okay, you can imagine, Rhino is difficult to manage, to scale, and it's easier to manage all those little animals around. So it is also easier to scale your application, smaller applications. For example, you can add resources to one module without affecting the whole application. So yeah, you have to split up the application into parts. This is clear about this story. Every team can focus on one part. So but yeah, how do you split up such an application? Yeah, of course, you can slice your monolith up with a domain-driven design. That is designing software that aligns your business needs, you can say. You can also say it is the map of the jungle. So you have to understand, firstly, with domain-driven design, your territory. So you can also say you have to understand your whole business domain. And secondly, you have to find the route in the jungle. That is your architecture, you can say. And thirdly, you have to identify all those little parts, domains, you can say, territories within the jungle. And those are similar with subdomains or bounding context, they call it. So you have heard now a little kind of terms. I'm going to explain a little bit. So how do you apply DDD, domain-driven design? You can apply it with strategic design and secondly, with technical design. Strategic design is about, it belongs to the problem space. So you analyze your business domain. This is you analyze the problem you want to investigate. And the outcome of the problem space is a bounded context that is, now you can say in this part, it is the bridge between strategic and technical design. And it is nothing more than a model, a starting point, and also a starting point to step over to the technical design. And technical design is for implementing your model in code. So first start with the problem space. Steps in your problem space is steps in a strategic design. Firstly, what I already said, you have to understand the territory, to understand your domain, and also you have to collaborate with a lot of stakeholders and all those to grasp what they are doing, what the domain is, what they're working in. And you have to define the core and the supporting domains. The core domain is the domain which is critical for your organizations, and the supporting domains are the domains which are secondary. You have to perform event storming, so you have to, within those core and supporting domains, you have also a lot of events, interactions. You're going to storm out, event storm out from what is all those events you have, and what are the links in between them. And then you can group those events together, which belong mostly together. And those groups of events, they call bounded context. So let's start firstly. Here you see also arrows. You have to evaluate, of course, each step. Let's start with understand the business domain. I show you an application, real-life application of the Dutch railway management system. And this is the first application we want to split up, because this is a huge monolith of the Dutch railway system. And here's a control center you see. And you can imagine they are following the trains on the screen, they are following the schedules, also real-time planning, all real-time data, so that's all interesting. But yeah, a monolith is very, when there is an issue in one place, it can have effect on another part, and everything is tangled together. So the first step is, of course, you have to understand the domain, the whole picture of the railway management system. And you have to understand the business requirements. So what are the business requirements? Real-time train tracking, okay, route planning, capacity management, now real-time infrastructure status. You also have to define an ambiguous language. This is not everybody speaks the same language, you can say. There's a common language that bridges the gap between the domain experts and the technical experts, and it is it's a common language, a shared language, and you can have also a living glossary you can make of it, where you define all the terms inside of it. And it can be, for example, train updated can mean something else. In another part of the application can mean something else than in another part of the application. When you say train position, can mean in one part of the application can mean the GPS location, and another part it is the track number where it is. Secondly, we step over to the core and supporting domains. Core domain. The core domain for the Rhino is, of course, the horn. So that is the way you want to survive you can survive in the, very critical to survive in the jungle. And the core domain of this application is real-time tracking of trains and real-time tracking of the infrastructure status. It's really a mission-critical part of this system. And the supporting domains are, for example, the planning part, the capacity and the schedule planning part. Performing event storming, we are event storming out all those events we have, train position updated, train delay detected, track status updated, etc. And then we want to group all those events together. And how do we do that? We have to see also the relations. We also have to ask to ourselves every time from what is our core domain we have defined, and what is our supported domain. And when you ask that, you can also better group them together to those domains you've defined. So we group them together to one core domain we defined finally with for tracking trains. You've already, and they have these events And a lot of the other parts we called subdomains. So we can identify now our bounding context, you can say. So the orange one is the core domain. And you can say that every bounding context, we give it a name, train monitoring, train track monitoring. And here we have a part is more about routing planning. And we saw also a relationship within track section monitoring. I show you the real application, so this is more than a concept for you now. And also, capacity planning. So all those bounding concepts are loosely coupled. That's good. So you can better move it around. Better, you're more agile and independent scaling. And all those events within the bounding context has a high cohesion. And every bounding context has its own shared language. So there's a little bit about DDD. So I'm standing there on the tree, and still I was so afraid. What is the Rhino doing under my branch? He was nearly touching my branch. I say it later on. Bounded context, here in the middle. That is the outcome of the problem space, and we step over to the solution space from this part. And bounded context as micro-frontends, microservices. You know all microservices, so we map out our, in this part, the bounded context to our microservices quite easily. You can say from, okay, this is it. But what's very interesting is here in this picture is that we are pairing the front-end part with a back-end part. So I recognize certainly a kind of architectural definition which is also like this. I see here an architectural style where independently deliverable front-end and back-end applications are composed into a greater wall. That's what you see here, independent. This is also the same definition for micro frontends. Everybody think about micro frontend, about frontend. Everybody think about micro frontend, about micro. Also not good. Micro frontends is the concepts of microservices are extended to the micro frontend, you can say, but micro frontend is also about the backend, also about microservices. So it's very interesting. Everybody think okay, it is only about front end, about CSS, and splitting up a little bit about applications, but it is the whole application with microservices. So we have created this architecture. Looks like what I've shown you already, but this is a little bit special. The special part is, of course, the host and the shell. That groups all those micro frontends together into a greater wall, according to the definition. Let's see the time. Okay, that's good. And the host and the shell is more than only a shell. It is responsible for routing, also for authentication, authorization. It also responsible for state management, for example. So it has a huge responsibility. And you see also that we have the backend and the frontend are here paired together. And in our application, we can load our application multiple times. So we can track the train monitoring sections from Amsterdam, Utrecht in one screen. And then 40 times, and it should, how can we do that performant? That is the question. You can say, well, front-end application, it does work. It doesn't work at all because it was in the beginning too slow. How do I solve that? I'll show you later on. Here I see the real application. I show you the real application within a few minutes. Here we track the trains in this part. That's the first application. And the second application is for train scheduling. Here you see the okay, the track section monitoring. You can see the trains which are here behind and in front of you. You're sitting in this train, you know it is has some delay behind you, or for it is too fast, 7 minutes, that is it. Maybe also this application, this is for the planning application. And you can see here the time a train reserves a track. So 801 is a track number, and there is standing a train which number 63127 for quite a long time. Technical design. Technical design is nothing more than your survival gear in jungle. In our world, it is are that entities and value objects and aggregates. Entities are nothing more than objects, like I'll show you later. Value also aggregates can also group all those objects together. I'll show you an example. If we want a micro front end, and we have a part is called train position, and that train position is a kind of subdomain within the micro front end, and it is an aggregate, and it beholds all those properties like train, entity, position, value object, timestamp, infrastructure condition, route. So there's more a grouping of entities and value objects. And an entity has an ID and is mutable, and a position is a value object and is immutable and has. I'll show an example of it. This is a train entity with an ID, train number, and a status. And here you have an example of the value object. A position can be a latitude, can also be a train section number for the position. It's not, okay, that's detail. And here you have a train position aggregate, which group all those entities and value objects together. You have also here a route aggregate I defined here. This is the main aggregate, and it is accessible from outside. And it is you can also save it in your repository, in your database as one aggregate, and it enforces integrity. So you can also define in your technical space, a solution space. You can also define your repositories. Here I have a repository for train position repository. Is nothing more than a simple map where I do a save and find by ID. And I do also real-time updates with WebSockets. From the backend to the front end, I use WebSockets for real-time updates. WebSockets is a kind of network protocol, two-way communication, and it's always open, so we can have real-time data of the train conditions and the train sections and train and the planning. And here you see a simple service where I update the train position. I save the train position in the database. You can do that or not. And then finally, I use a message template. This is Java, what you see here, where I put the train position on the topic. And you can, in the front end, you can listen to the topic for the train position. So in the front end, we use RxStomp for WebSockets. And this is the final sheet. I'll show you the application now. Here you see that I watch to this topic. Okay, how do I build my front end efficiently? I use Module Federation. Have somebody heard of Module Federation? Are you glad about it? Who is not glad about it? Okay, interesting. I'm glad about it, because quite used application. We use Monolith Federation. It's like a group of rangers who work together efficiently, and they also share their own knowledge, let's say resources or dependencies, very efficiently with each other. That's the strength of Monolith Federation. You have two roles in Monolith Federation: host in a shell, you know that, in the micro-frontend world. And you have remotes, those are my micro-frontends. And here in 2022, we started with this application. This architecture, of course, also, it's quite good, but the downside was we were starting with web components. And it's quite good, web components, but the downside in our solution was we have to load our micro-frontends multiple times. Train infra tracking, route management on one screen. And every time we load one tile, one micro-frontend on the screen, you load Angular separately. So our application slows down dramatically, so it didn't start up anymore. And also a lot of version conflicts. The shared libraries were also loaded multiple times. So we stepped over to Monolith Federation, and the big part is that we have to load our Angular application, Angular library once, or framework, sorry. And it is unbelievable fast. It was speeding up our application from 30% lighthouse to 80%. So it's about code sharing and about, yeah, that speeds up our application very much, of course. You can independent deploy your front-end application quite easily with Monolith Federation and also with micro frontends. Lazy load your applications. You're technically agnostic. In the front end, you can choose your framework, what you want, and improved performance. Let's go for a demo. How much time do I have left? Okay, right. Demo. Okay, for your disappeared suddenly. Okay, sorry. It's not really what I wanted. Okay. Okay, now to log in again. You see an application. You see I loaded here the train tracks, and you can here load a lot of the same style I can load here of different parts of Netherlands. I can go to Amsterdam, Almere Centraal. We can load here, and we can here select another one and follow the trains. You can also select other regions to follow the trains on the tracks, etc. Here's the bigger part of it. You can also seek a train or a section in Holland, in the Netherlands. Let's say, if it is working now. Okay, now does it work? The internet connection is not well, I see. I step over to AI now. You've seen that this application works. Come on. Okay, thanks. Okay. Come on. Come on.